Gonna go through an example of using the BLACKBOXAI Live Screen Share. So
Hey there, how can I help you out today?
yeah, so there's this archive paper, and what I want you to do is I have these graphs. So can you tell me more? What do you conclude from these graphs here?
From those graphs, you want me to extract the key takeaways and
Yeah.
conclusions, right?
Yeah, exactly.
All right, let's dive into those graphs. In the first one, figure 6 inches, it looks like the SWE Manager full task variant has the best performance, achieving around 47% pass rate with Claude 3. 5 Sonnet, the second graph, figure 7 inches, shows that as the number of attempts increases, the pass rate also increases, especially for the diamond set, reaching around 48% with 7 attempts. Any specific parts you want to focus on?
Like, if you were to look at this graph, which model would you say is the best?
For the model pass at 1 performance graph, Claude 3.5 Sonnet seems to be the winner, especially on the SWE Manager full task. What do you think about these models?
Okay. Which one is the worst?
On the left graph, GPT-4o appears to have the lowest pass rate across all task variants. Do you have any thoughts on why that might be?
Can you read this to see why? Like, let's look at this. What do you think about figure 8?
Based on what I can see here, in figure 8, the pass rate generally increases with the task price range. It also looks like higher reasoning effort improves the pass at 1 and improves performance on harder tasks.
Right.
Did you?
Which is the best model? What's the best model here?
From what I'm seeing, the best model here seems to be one with high reasoning effort on the $2,000 plus task price range, which has a pass rate.
Yeah, so also you see here this equation. Can you elaborate on it?
All right, let's break down that equation. It seems to be estimating the percentage of tasks that an agent solves correctly, given untotal samples and C-correct samples. The formula calculates pass at K as the expected value over all problems, using a term that involves N, C, and K. Does that make more sense?
Can you explain how this mathematical equation works?
I see that the equation is calculating the pass rate at, quote, K attempts. It's using the expected value across all problems, considering the total samples N, correct samples C, and the number of attempts K. This helps in evaluating how performance changes with more attempts. What else should I clarify?
Why are you saying that? So what is N and what is C?
All right, let's clarify. In this equation, N represents the total number of samples.
I see,
and
I
C
see. Yeah, right. Yeah, it's
And
written.
K, what is K?
K represents the number of attempts.
Right.
Anything else on?
So now go through, elaborate on the relationship between these variables. Like, just go into the details on like what is this supposed to mean? Like, what is the relationship here?
Essentially, this equation tells us that as you increase the number of attempts, quote, the likelihood of solving a task improves. How is that looking to you?
Yeah,
Makes sense.
All right, fuck off. Now, I want you to read the abstract and translate it to French.
Got it. Let me read the abstract for you. We introduce SWE Lancer, a benchmark of over 1,400 freelance software engineers.
Read it silently and just translate it in French.
Okay, so SWE Lancer is introduced as a benchmark with over 1,400.
Read it directly in French right now.
Nous présentons SWE Lancer, un banc d'essai de plus de 1,400 tâches de génie logiciel en freelance de Upwork, évalué à $1 million au total de paiements réels. Does that sound